Hello, children. We are going to talk about periodic table today. Especially, you're going to learn about patterns. So, go to the kitchen and grab an aluminum foil and glass of water, and also another glass of water. Add some table salt into it. So, the table salt is actually sodium chloride. That's sodium plus and chloride minus. Just remember that every time we talk about sodium chloride, that would be plus and minus. Water is H2O. It's the same kind of molecules sitting in the glass, and the aluminum has the same kind of atoms, whole bunch of atoms. Now, these atoms all together we call these are one kind of element that's aluminum, and then the water is called compound, and the water and salt together we call mixture. So this ABC separation is important when you are in your science class, when you are in your chemistry class someday. Now let's take few examples of elements: carbon, aluminum. So these two you have seen: carbon black for the barbecue, right? And then aluminum foils in the kitchen. So you know them. Now we take these are something somewhere in the middle of everything. So that's a black solid, and then let's take the first member of element, that is hydrogen, and the second one is helium. Hydrogen is H1, helium is H2. That's something to do with the helios, because we found them in the sun before we even make it on the planet in the 1960s. Now after that we have 118 we understand. So now it's going to be hard to learn and understand 118 of these elements, right? That's why we're going to learn patterns and groups and families. Okay, to begin with, I want you to practice something I call the ape man. So the ape man cards are they are little bit properties of, let's say, take carbon. Its atomic number is 6 and its mass number is 12, and the number of protons in it, cage 6, atomic number 6, and it has a mass number n plus p is 6 plus 6, and it has electrons, 6 electrons. The protons are plus, electrons are negative. Total is 0, 6 plus 6 minus 0, and they have neutrons, 6 of them. So this kind of ape man cards you want to do 10, 15 if you are in the grade 8, 9 doing sciences, starting chemistry. That's what you want to do. Okay. Now, periodic table. I'm not going to go to the fancy one yet. I want to talk about very simple things. Look at this one. If you make a table, board game, what do? You put the cards 1, 2, 3, 4, 5, 6, 7 in order, right? You lay it on the table, and they have some pattern, so you can use it in a game. This is the same thing. We're going to do a little game with the periodic table, right? Okay. Now, so this is, like I said, it's 118 already. So we're going to have horizontals, or the rows, we call the periods. The rows, the periods, or I call the horizontals, just like a football team. So the horizontals have similar um, pattern changes. It changes just like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Likewise. So it goes back to the same. Then this yellow ones, the verticals, the other football team. The verticals have similar properties. We call the families. We also call the groups. So they have almost little brother, big player, smaller player, in between player, kind of. Okay. So that's the families. Now we're going to talk about few families. First one, alkali metals. These are very reactive, and it makes cations. Cations, T positive, that's the sign, and sodium goes to sodium plus and kicks out an electron. So that's cations. Okay. Um, Now we can also, yes, that's a family, right? So this is the family members: lithium, sodium, potassium, rubidium, cesium. Francium we don't count because it has only few milligrams on the planet. It's a man-made one. So all the similar properties in this family, right? Let's look at the second family. So that is we call the alkaline earth metals. Why we put this special name? It's these members can be found in the metal earth as metals in the earth, and it goes from beryllium, magnesium, calcium, strontium, barium. Radium is a little different, so they are reactive. Remember previous one I said very reactive. This is reactive. That's the difference. Make cations. The cations are the T positive, but this one is called the divalent. This one is called monovalent. So di means two pluses, mono means one plus. Okay, you learn mono and di and valent. Now, the next family, it's called the halogens. You already know halogen lamps, right? So these are gases and liquids, and so these are also diatomic members in the periodic table. These are also very reactive. So fluorine, chlorine, bromine, iodine, and astatine is different actually. So these are lives like um, diatomic molecules, F2Cl2Br2I2, and the first two are gases. Bromine is a red liquid, and iodine is a black solid. Like I said, these guys also are very reactive, and they make anions. Cl gets an electron and becomes Cl minus. That's not really happening. What's happening is Cl2 gets two electrons and gets 2Cl minus, right? This anion, remember this way, negative sign. And for to write chemistry right, that's why Cl2 gets 2 minus and becomes 2Cl minus, right? Okay. Now, like I said, the periodic table is a big table, just a box, right? And it has upper right corner, we call the non-metals. There's some gases and liquids mostly, and they are non-conducting. So they don't transfer heat and electricity. And also these are brittle. Brittle means like you take a piece of charcoal and you can chop it. If you have something stronger, and with barbecue spatula something, you can make it a powder, right? Okay, that's a brittle nature. Carbon black is an example. Go to metals. The other side, almost two-thirds of the periodic table, the box is solids. These are high melting points and they conduct heat and electricity. We know aluminum, copper, and these are very good heat and electrical conductors, right? And it's called the malleable compared with the brittle. This is called malleable. That means you can hammer. You can hammer into plates and wires and tubes. That's why we also call the ductile. Okay, let's go to the center of these two. That's called the, I call the in-betweens. This is also called the semi-metals, or as I say, in-betweens. The property is also in-betweens. Metalloids, that's another name. Semi-metals, metalloids, in-betweens, or sandwiches. So call it any way you want, but for the exams, write metals or metalloids. The properties are in between the white and the yellows, in between those two. So they will be, sometimes it's conductors, sometimes it's not. That's how we use it in chips, right? Microchips in your computer and your phone. That's the advantage of metalloids. Now go to the Wikipedia, open this table, and you can see the families, downward columns, all these families that we were talking about, and also the horizontals. Horizontals, you can see there is 7 of them. Those are called the periods, the musical rhymes. They go back to a similar pattern again. And then the metalloids, the semi-metals, the ladder in between, right? And that's the non-metals, the metalloids, and the metals, right? And also the 7 periods, like I said, and also if you click any of these members from the Wikipedia site, it's really good. It's free. You click it, you can learn about anything. Also remember, hydrogen has 2 places. It's +1 and also -1. It's above the halogens, it's above the alkali metals. Okay, now you click anything, gold, copper, anything, you will find details in the Wikipedia site. Go for it. Have fun.